Hey everyone, welcome to my channel. Today we are diving into Kubernetes architecture, but we are going to keep things simple by breaking it down using something we can all relate to, a company's organizational structure. Whether you are in a management or just curious about Kubernetes, this analogy will help you to grasp how this powerful system works. So let's get started. Imagine a company like any organization within various departments and teams working together to achieve the company's goal. Well, Kubernetes operates in a very similar way, coordinating and managing different parts of an application to ensure everything functions as a cohesive unit. So here we can see we have organization with different departments, and in departments we have different teams, and in teams we have employees working for a specific project. Let's begin with Kubernetes cluster. Think of it as the entire company. just like a company just like a company has departments and employees each responsible for specific tasks. Kubernetes cluster has nodes and pods working together to keep the whole system running smoothly. These departments represent nodes in Kubernetes. Each department, like a node, provides the resources needed, whether it's compute power, storage, or networking, to run multiple applications. Or, in our analogy, it's multiple teams. Within each department, we have teams. These teams are like a pod in Kubernetes. Each pod handles a specific task or project, just like a team working on specific project within a department. Within these teams, we have individual employees. In Kubernetes, these are the container inside the pods. Each container is like an employee handling specific function, whether it's processing data, serving web pages, or managing databases. Every container has its own job, and together they help the team or pod to succeed. Now that we understand the basic, let's take a deeper look at how Kubernetes architecture maps onto this company analogy. So this is the Kubernetes architecture. At the top, we have master node, which is control plane, which you can think of the building of management office. This is where the big decisions are made, ensuring everything in the building runs smoothly. The API server, a crucial part of the master node, acts like a front desk or receptionist. It's the main entry point for all all requests coming into the cluster. Just like how receptionist manages who comes into the building and directs them to the right department. So this is how all the requests, incoming requests, API server handles, and based on the request, it redirects those requests to particular department in control plane, be it cluster, is it etcd cluster, control manager, or scheduler. In Kubernetes, the API server's function is to handle the request, validate, and configure data, and manage user authentication. It's essentially the gateway to the cluster's control plane. So it's like gateway. It acts like a gateway for the control plane. So whenever anyone wants to enter the control plane, they have to go through the API server. Inside the building management office, we have controller manager. This role is like operations manager who ensures that everything is running according to plan. If something breaks, like a pod failing, the operation manager ensures it's fixed quickly to maintain the desired state. The control managers is to monitor current state of the various components within cluster via API server and works towards to bringing them to desired state. For example, it ensures that inner pods are running in healthy state or not. Next, we have scheduler. So it's like a facility manager in organizational structure. The scheduler decides where each employee's or workload should be placed based on available space and the company's needs. They make sure resources are used efficiently and no department is overloaded. The scheduler function is to assign pods to nodes based on the resource requirements, ensuring that pods are placed efficiently within the cluster. Then there is a etcd cluster, so which acts like a building's record or blueprint. It stores all the critical information about the building, like whether the departments are and how everything is laid out. This ensures that the building or cluster operates smoothly and that any changes are properly documented. The function of etcd is to store all cluster information, including the current and desired state, and to act as a data store for Kubernetes, kind of database you can say, and maintaining coordination between the rest of the components. Now, as we completed the control plane, let's move towards the worker nodes. So worker nodes are where the workload is placed on or where the pods are actually running. So within each department, so consider they are different departments. So it's like a master department or management department. We discussed about the control plane. But for the worker node, consider they are different kind of departments. And within each department, we have department head that we can relate to kubelet. It's like a supervisor. The kubelet ensures that all employees or containers in their departments are doing their jobs correctly and everything is on track. They also report back to building management office about the department status. So whenever pod is running or it's started, the kubelet informs that the pod is started to API server. And then API server passes that information to etcd cluster control manager. Or whenever there is a pod without a node, it passes that information to scheduler that there is no node assigned to pod, and you have to decide on which node we have to place that pod on. The kubelet function is to manage the node and ensure that pods are running as expected while communicating the state of container back to API server. Then we have kubeproxy, which acts as a building's internal communication. It ensures that different departments and teams can communicate with each other. So we have learned departments are nodes and teams are the pods. So the kubeproxy ensures that there is a communication. The pods are communicating with each other or not. So it's responsible for routing message and data between different parts of building or nodes. The kubeproxy function is to enable network communication between pods and services. And finally, we have container runtime, which is like the workstation setup for each employee. It's responsible for making sure every employee has the tools and environment that they needed to perform their job. Just like how the container runtime ensures that containers have everything that they need to run smoothly. The container runtime function is to run containers by setting up the container environment and ensuring all the necessary software dependencies and libraries are available and functioning correctly. So, what is the example of container runtime? It's container D or Docker. So Docker is responsible to create containers and it provides platform to create container in Kubernetes. So I hope this analogy made it easier to understand how Kubernetes works behind the scenes. If you found if you found this video helpful, don't forget to hit the like button, share it with your friends, and of course, subscribe to my channel for more tech insights explained simply. Thanks for watching, and I'll see you in next video.